Hello everyone. My name is Joseph Rabidou, and I am a student at LTU, Lawrence Tech University. It's in Michigan. I think they have locations elsewhere, but where I'm at is in Michigan, in Southfield. And I'm going to be doing sort of a tutoring video thing, I guess you could call it, for all my classes for all the years that I'm here. So this video is just a introduction, and it's also a test, so I can test like resolution size and the best things like that, so you can see it very clearly and there's no complications. Just right on here, I'm going to test it with my voice. This is the program I'll be using to work out all the problems. It's called Microsoft OneNote, and I think it handles it very well because up here at this tab that's lighting up, it you can add as many new sections as you want, and inside of those sections you get more of these here, more like little subsections. And then if you wanted, you can even add a subsection. So it's a really nice program to work with. But I guess I'm just gonna do a short tutorial on some circuits. So I want you guys to let me know. I know there's not going to be too many of you watching this right now, but I have all different kinds of graph papers, and whichever one you think would be best for you to learn on. Something small. I can write really small if you want me to, like, you know, f of x. You know, I can write small or whatever suits you best. So for now, I'm probably just gonna use this line paper. I'll mix it up, maybe, I don't know, but here, maybe we'll do this. Maybe we'll go with this graph paper. Okay, well, let's do some circuits. So here, let's not put that there. Let's get it up here. I'm using a touch pen, like a tablet PC almost. The Fujitsu. I think it's a T900 or something. The school gave it to me. Let's name this circuits. Alright, and then we'll name this first one Ohm's Law. Ohm's Law. I'm sure that you're all familiar with it already, and you're going to be like, oh my god, you're teaching us something so simple. Again, this just is like an introduction video for one, and I got to start somewhere where everyone will be able to relate. So, Ohm's Law. To know Ohm's Law, this might be really simple to you, or this right here might be Chinese. V equals I times R. Now, if you're wondering what V is, sorry, hang on a minute. Counting change on my desk and it's getting in my way. So, if you're wondering what the V is, it stands for voltage. And the I stands for current. I know that seems weird that I stands for current, but it's just how they did things. And the R stands for resistance. Alright? So that right there is your basic layout of Ohm's Law. And you use that layout inside of circuits to find different parameters on circuit elements. So say you have this circuit. Well, I can probably make this a lot bigger for everyone. You have this circuit, and you have this source, and this source is putting out some voltage. We're just going to call it V. Alright, and the circuit has some resistance. Alright, now I know that's a really crappy diagram, but I didn't set my timer, so I don't know how long I've been doing this. Now you have current, conventional current, says it comes out of the positive lead because it's the current. It's the flow of charge. And the convention for current I'm going to use is the flow for positive charge. And to get a little bit more in depth with that, electrons are really the only things that can flow. Those are coming out of the negative terminal, because electrons are the only thing that's free. The positively charged things are things like protons, and those can't move. But because these electrons are moving this way, for relevance, it appears that if you're looking at it from a charge point of view, that positive charge would also flow this way, even though it's not flowing. So I'm going to use the conventional charge flow, which is the flow of positive charge, which is the red arrows. And then up here you have a resistance. If I do that in black, you have a resistance, and this is a current. And use Ohm's law together to find what the resistance is if you have current and voltage, or to find what the current is if you have voltage or resistance, or to find what resistance is if you have current and voltage. So I'm just going to write those equations down. Oh, turns out my camera's halfway off. Sorry about that. I couldn't even see. Well, now you can see the whole thing, and I wrote down the definition for current down here. I'll box that in and you'll see that. Alright, and then you can see the rest of the circuit, what I was talking about, and I'll highlight right now. This was the resistance. This is a voltage source with voltage. And this is our current. Conventional current flows in this direction. And I'm going to write down these quick equations, and then I'll do an example in another video. So, say you know resistance and you know current. You can say, and you want to find voltage, you can say voltage is equal to the current times the resistance. Alright? Now, all you need is two of these to be known, and the other one you can solve for. Now, if you know current and you know voltage, then you can say resistance is equal to voltage over current. And you can see from basic math that all I did was divide the current over to get the R by itself. And then if you don't know current, and that's what you're looking for, you know resistance and voltage, you can say that current is equal to voltage over resistance. So they have proportionality between them, and they are related to each other. That's something to think about. So that's the basis of Ohm's law. He derived this. I'm not going to do the derivation for you, just because I plain don't want to. But yep, think about that, and I'll get another video up. And if this resolution doesn't work, I'm probably still going to put it on there anyhow, even if it looks crappy. So don't yell at me.